and this special interest group to present their status. And what I'd like to do a little bit of a change is that I'd like to present it to hang on right after your presentation to start taking questions. I know that for this portion of the workshop, there's going to be a lot of discussion and engagement because they talk about specific work items or to-dos or what's next on the agenda, things like that. So I like for the question to be answered to be presented right after they finish presenting. All right. So please hang on for the Q&A right after. All right. So with that, I think according to the plan, looks like infra and architecture will be up next. So let me put up the slides. Okay, so I'll share screen. All right. So Rama?
Yes, hello. Can you hear me?
Yeah, I can hear you now. Yep.
Okay, good. Hello, everyone. This is Rama. Unfortunately, neither Ka nor Lou from the infrastructure SIG is able to join us, so I will be making the presentation on their behalf. One of the most notable extension to ONNX in this release is that the model format has been extended to support training. This is currently a tech preview, and I'll say a bit more in the next slide. There's also a significant extension to the expressiveness of the function construct in ONNX, and I will say more about that also later. And finally, another exciting ongoing work is on ONNX MLIR. This is work in progress where a group is investing in building an MLIR dialect for ONNX as well as other infrastructure to help lower the ONNX dialect into standard MLIR dialects and so on. Next slide, please. There's going to be a later presentation by Svetlana covering the training support in ONNX. So I will just give a very brief view at this point. The extension is a backward compatible extension of the ONNX proto format. It allows user to describe the key ingredients of a training spec, namely, it allows us to identify a set of weights that need to be trained, and it allows us to describe how the weight should be initialized. It allows us to describe how the weight should be updated in one training step. So two key extensions that are used to enable this are a special operator called the gradient operator for computing the gradient of some computational subgraph, as well as another operator called the graph call operator that allows us to call another graph. And in particular, this allows the training step to call the inference graph, essentially. And so just a couple of more, as you all know, ONNX has been primarily a functional that is side effect free without the notion of assignments or side effects. Once we have training, of course, it effectively you need to describe have some side effects because the training process is going to update the weights, and as shown here, basically we use a notion of a binding to effectively specify updates to weights, and hopefully Svetlana's presentation will cover more details of the training support. Next slide, please. So one of the dilemmas we face in the context of ONNX relates to the set of operators On one hand, we have new models, new applications, and new research driving the need for new operators. But there is a cost to adding new operators in terms of developer cost to support it in the backends. And if you want to optimize it to exploit hardware features, there is even higher cost in implementing it. And the function construct was introduced in ONNX to help deal with this trade-off. Basically, this allows the ONNX spec to describe a default implementation of an ONNX op in terms of other more primitive ONNX ops. This allows backends that don't have a customized implementation of the op to use the default implementation. This gives backends the flexibility to add customized and optimized implementations at their own pace without compromising expressiveness. So the construct exists, and going forward, we would like to make use of the function construct more effectively. In particular, we would like to identify a core set of primitive ops and that can be used to express other ops as functions of these primitive ops. And we would like to leverage the learning from many implementation frameworks, including ongoing work in the MLIR space in compiling models down to hardware. And this is also related to the ongoing work on MLIR. So the goal of ONNX MLIR, as I said earlier, is to define an ONNX dialect in MLIR and identify ways to lower the ONNX dialect into standard MLIR dialects. And so as I said, there is ongoing work. Next slide, please. So let me now briefly describe the extension to the function construct I mentioned earlier. So the new API allows us to define functions where the function body depends on statically available context information, such as the values of attributes or types of inputs. This is useful because we don't want to incur a runtime cost for making choices that can be done statically on the basis of statically available information. So I think this makes the function construct notably more expressive, and as the slide says, there are examples, specific examples that show how this can be used. And one of the other extensions is now we can, as you know, there is a notion of operator sets, and originally the model can specify the offset it depends on. Now the extension allows us to let functions also specify the external operator sets that this function definition depends on. Next slide, please. So finally, there is interesting and important work to be done, and we welcome your contributions and participation. If you have a backend for ONNX, it would be great if you can register your backend at the link shown here. Some of the other ongoing work includes improving the testing and checking infrastructure, improving the build and setup process, release process, CA, and so on. So that's the end of my presentation. So thank you.
Great, thank you, Rama. So any questions from the community for Rama? I think someone's trying to talk. Go ahead. So Rama, maybe I can ask the question. So you talk a lot about the ONNX MLIR. Is that going to be part of this infra architecture SIG, or will they form a separate, maybe given the level of interest now with MRR, would that be a separate your working group or SIG to focus on MRR?
That's a good question. Actually, maybe Prashant.
Yeah, it's the repository is owned by the infrastructure and architecture SIG, so it's part of this SIG.
Okay, all right. So we'll be working closely with Rama and Kerr and Lu Feng. All right. Any other questions? All right. I guess if not, if you have any questions later on, please feel free to post in the chat window. So with that, I think we can let's move on to the next presentation. So converters. Okay, did we skip? I think the operators.
The operator, I am here. So
yeah, can you share screen?
Yeah, I can share screen. Yeah,
with your presentation.
And I sent you the presentation by email because I didn't have access to permission to upload in the Google Drive. So, okay, so let me share the screen.
Oh, okay, I missed that. Okay.
Yeah. Okay, can you stop your sharing because I cannot share while you are sharing?
Oh, sorry. Sorry. Okay. Are you okay? Can you share now?
Yeah, I will share now. Do you guys see my screen?
Yeah, I can see it now. Thank you.
Okay. Thanks everyone for coming. So I am Imad Barsoum. Me and Michal, we lead the operator SIG group. Sorry, Michal cannot attend today. So currently, this is the agenda. We'll talk about overview about the operator SIG, then the coming release, which will be released too soon about ONNX 1.7, then dynamic shape, which we discussed in the last workshop, but we made a decision during the operator SIG meeting, and I will discuss the final decision and why. Then some discussion about coding style, PR, and some other issue. So first of all, let's discuss and to repeat what is the goal of operator SIG. We have 5 primary goals that we are trying to adhere to. First, keep up with the latest AI progress and make sure that we have your list of operators that cover new models that are ready for production. Improve the quality of ONNX operator, and this is very challenging, and I will discuss later why. Reduce ambiguity and increase the clarity. A lot of operator, if the description, if it's not well defined or the unit test is not comprehensive, different runtime might interpret it different, and this is something we are trying to address them. Avoid ONNX bloating the spec. The goal of ONNX is not to be the kitchen sink of all possible operator from all possible framework. ONNX is designed to be interchangeable format for inference and for training, but the focus more on operators that are already in production. You can add custom operator on it, but the focus is to keep the spec small, but cover a lot of primitive ops that from it you can compose to more complex op. Keep up with PR and open issue, and this is we need all the help that we can get. Okay, we have a lot of participants that attend our SIG meeting group, so feel free to join. Here, our communication, we have a channel in Getter, operator channel, where we discuss all the issue. Also on this channel, we announce our meeting with link to the Zoom link for the meeting itself. So it's any meeting we do for the SIG meeting, it's open to everyone. So feel free, check the channels, check any announcement. Also, if you have any issue about operator or question follow in the channel. Also, you can open PR and issue regarding operator. The doc of the operator is and all the meeting note is under ONNX SIG operator. Last workshop, we discussed the criteria of adding new operator. This has been ratified and updated during the SIG meeting, and the final doc is in add new op. This is covered both adding new op and updating existing one. So before you propose or submit a PR for new operator, please go through this document and make sure you adhere to the principle provided in the document. ONNX 1.7 will be released pretty soon. On it covers a lot of new update from the previous release. Primarily, the major update, as Rama said, is the training. So now we have loss function like softmax, negative log likelihood, and mean square. Operator, there are operator for the training and operator for not only training. The biggest operator that got added that was highly requested by a lot of people is Einstein sum notation, which is available in most framework, which is very flexible to do any mathematic or tensor operation on it. There are other operators like greater than equal or less than equal and unfold inverse. Some of those operators are actually a function. The biggest one of those besides the Einstein sum is gradient, and this is for the training. So gradient operator actually generates the gradient of a graph. Quantization, we already have quantization operator get added in ONNX. We updated max pool, reduce min, and reduce max to support int8 for quantization. For training, we added momentum SGD and add a grad for the optimizer. One of the things that we are lacking, and I would love to have more people to participate, is PR and GitHub issue. Currently, we are trying as much as we can to address them and close them. And currently, we still the number of PR and issue that open is more than one. The velocity is more than the one that we close. So please, as much as possible, help in those regard. But we are trying to address or look at most of the PR and issue. Some of the PR propose I want this op and I want this op. Feel free to submit a PR of this op, assuming it's adhered to the requirement of add a new op. It needs to at least to be available in a framework, and there is a model that use this op. So any PRs that for operator, we add label operator on it. So it's easy to filter and to see all the PR and issue that are related to operator. Contributor group, we review the PR according to the add new operator guideline. And based on this feedback, if it's signed off, we will merge it. Any big PR or big change, proposal change, we usually will invite you to attend the SIG operator meeting to review it and have an open discussion before we move forward. Final approval is done by the SIG operator approval group. We have also a lot of open discussion about operator in GitHub. And we are active in GitHub to discuss any operator issue or PR or on Getter. We decide when some of the discussion we decided once the discussion is done to be closed, is still look for the best way to triage a large number of open issue. Feel free to propose any improvement for the operator or the process, for example, better testing, validation, or coverage for ONNX operator. Feel free to propose more better documentation. Even submitting a new operator, there is some manual step, so feel free to propose or submit a PR to automate some of that work. For any big proposal, as I said, you will be invited to the SIG meeting to present them. We discussed last workshop dynamic shape. Currently, ONNX standards support a dynamic shape and have a loop and a variable length input. It depends on the model. And this is problematic in accelerators or IoT devices with limited memory. So in last workshop, there was an open discussion about should we add a flag, should we add a hint to the size, and we discussed after the workshop follow-up meeting with a lot of our partner, and in that there are 3 cases. For example, inferable op, not inferable op, and dynamic input. For example, non-zero op, the output can depend on how many non-zero. Should we put a hint? Should we have a mode, an attribute to fix the size? And boil down the discussion to what should be part of the spec and what should be runtime implementation. If we added maximum size hint, this should be part of the spec. ONNX runtime is a disk format. Once you load it, you can convert and add any restriction you want. If we add max size hint, who decides that? Is the researcher that created the model without knowing which hardware it will run on? Is the engineering that deploying this as hardware? If the size usually is not fixed, it depends on the target hardware and its limitation. If it's hint, it can be ignored. So if something can be ignored, is that can be part of the spec or should be implementation detail? Even if some op can output variable size, the underlying implementation can have a fixed output size, and anything beyond that, it can be clipped or error out. It shouldn't. So eventually, the SIG operator group decide that dynamic shape, it shouldn't be part. Fixed size, it shouldn't be part of the spec and should be runtime implementation. Any questions so far? Okay. Next item is coding style. If you look at some of the operator, we have an op convention MD file to discuss what's the convention about the coding style of submitting a new operator in ONNX format. Currently, how many people know actually that we have an op convention MD file? And if you look at some of the operator, we are doing a lousy job to adhere, even in the PR review, to adhere to this convention. In some of the operators don't actually adhere to this convention. So is that something, should we enforce it? Part of the CI? Should we add the code check that you are using camel case, capital or not? So when you submit a PR, it will fail. And automate this, something we will discuss soon about automating adding a coding style verification in any PR that get checked in. Question? Okay. Another issue, PR and issue. A lot of time we see people opening PR and we ask a question and we don't get any reply. So if the author did not follow up in X week, should we close the issue? And what is the good value of X? Should we close after 4 weeks or 3 weeks? So we'll start to clean up the number of PR and open issue. Anything that is not addressable or there is no follow-up, will close it, and the author are welcome to reopen it again if still there is an issue or he or she wanna follow up on it. So also, if a PR open, currently the number of people that review PR and issue are very few, and some of the PR fall under the cracks. So how long should the PR be open, and should someone before reviewing? We want to start asking people for help and try to see how we can have a better turnaround in reviewing PR and issue. We are also open to how to improve the process. If anyone have a proposal or better idea, it's all welcome. Feel free to propose it in Getter. Feel free to attend the SIG meeting and proposing. One of the things we noticed recently is that fewer and fewer people are reviewing PR and issues. So we are trying to see how what can we do to improve the process. Thank you for coming. Please look at Getter's channel for any announcement, and also feel free to ask questions there. Operator artifact and documentation are all under our SIG group. Thank you. Any question?
Yeah, thank you, Iman. I think there's one in the chat. I guess Raphael asked, since the operator should stay primitive, is the goal to have the translation from more complex operators to simple one part in the converters?
That's a great question. There are two answers to this, and Rama already mentioned that in his talk. We have a function. So operator, we are trying to be primitive, but to any complex operator, we can write it as a function. And this is give you the best of both worlds. So you still, the converter can convert to a function and not operator. It's up to the converter, of course, choice. They can convert directly to the primitive op. The function itself is have a graph attached to it, which is compose the primitive op to implement the function. And runtime, it's up to them. If they don't want to implement the high level op as a fused op for performance, they can simply evaluate the attached graph. But if they want to improve the performance, for example, or having hardware accelerators that implement this as a single function, they can ignore the attached graph and implement the function as one fused op. So operator, we are trying to make operator more primitive, so give you more flexibility to implement complex op. However, some complex op will be submitted as a function. So similar, the loss functions that you see for the training are all function, none of them are operator. So it's up to the runtime that can optimize it on it, and this will help the converter does not need to convert everything to the low level op.
All right, thank you. Yeah, and there's another question. There was a spec related to sparsity in the past. Can you shed light on how sparsity support is progressing on ONNX?
Yeah, so we have a sparse support in ONNX. Rama was working. Rama, can you talk about the state about sparse in ONNX?
So basically ONNX format has support for representing sparse tensor constants in the model file itself. Sorry, I didn't completely follow the question. Is it about, are you talking about using sparse representations of tensors in a backend at runtime, or is it about sparse tensors stored as constants in the model file?
Can you hear me?
Or as an input? Yeah.
Yeah, so Rap, can you clarify?
Yeah, can you hear me or?
Yeah, we can hear you.
Yes, we can hear you. Yeah. We are not hearing you now.
I think I'm having audio issues. I'll probably just type or take it offline. I'll probably just take it offline. Thank you.
Okay. Okay. Any other question?
Yeah. Do we have a structured process for working on these soft issues you're raising? I guess there's some overlap with infra, but it doesn't seem like any one group has a real drive to improve docs issues and throughput, etc. I mean,
we discussed that in the SIG meeting, but yes, we need more people to participate. I think that's what boiled down to it. Yeah. And that I think across the board, not only on operator. Yeah.
And the ownership is actually pretty split between infrastructure and operators. So any documentation related to operators, any bugs related to operators are all handled by the operator SIG.
Yeah.
So.
Yeah.
All right.
Yeah.
Okay. Any other questions?
Yeah. For example, in this workshop, we have more than 100 people. I hope that I see more than 100 people active in the GitHub.
Yeah. So I think that's the best way to get involved. Yeah.
Yeah.
All right. Final question? If not, I'd like to keep moving. And after operators is converters. So
Okay, thanks everyone.
All right, Jin, would you like me to share the screen? I can.
I already ended the sharing.
Oh, okay, all right. So Chin, over to you.
All right, can you see my screen now? Okay.
Yes.
Yes.
Yeah, thank you. Hi, everyone. I'm Chin Huang with Gunther Schrommling, co-leading the converter SIG. Today, we also have a few others to provide the latest updates. First off, can you do a quick poll, if possible? We will review the results. Let's move on to the front-end converters. So Emma or Gunther, please go ahead.
Yeah.
I can take it. Yeah, hello, I'm Günther from Microsoft with a few converter updates. For PyTorch, for the PyTorch exporter, the current PyTorch version 1.4 supports offset 11. And the team was working very hard on adding new operators, several, the main feature, a new feature is that we can export models larger than 2 GB, what you would need to do for GTP2. There's more integration with the ONNX checker to make sure the ONNX model popping out of the exporter are correct. And there are big improvements for the out-of-box conversion. So Hugging Face, BERT, and GTP2 models will work out of the box, and pretty much all the PyTorch vision models with offset 11 will convert out of the box. Next. For Keras, offset, the released version of the Keras to ONNX converter support offset 11 and TensorFlow 2.0 and TensorFlow 2.1. The master supports TensorFlow 2.2. Bidirectional ONN is fully supported. And there was a lot of out-of-box model conversion testing for pretty much all the Keras applications and for Hugging Face transformers. For sklearn ONNX converter, we support offset 11. And there are additional models coming up in sklearn 0.22 that are supported. And new features are Boolean input type and decision functions. Both Keras and ONNX converter, the Keras to ONNX converter and the sklearn converter, they support a common library called ONNX Converter Common. That library has a graph optimization in it, and the team has made a lot of improvement on the graph optimizations. So they see quite a bit of improvements on the number of nodes, like a reduction on 50% of the nodes and quite a bit of performance gain because of this. Next is TensorFlow to ONNX. The release version supports offset 7 to offset 11 and TensorFlow 1.5 to 1.14. And after 1.14, the TensorFlow release 1.15 is a bridge between the TensorFlow 1 and TensorFlow 2. So there are quite a bit of changes required to get TensorFlow 1.15 to work. And that support is in the master. And it also includes experimental support for TensorFlow 2.1 and 2.2. So in theory, you should be able to take a TensorFlow model in eager mode, and you can export this directly to ONNX. There are still a few issues with the TensorFlow 2.0 support. we still have some issues with the LSTMs. The unit tests for those are not enabled, but we are working very hard on this. Yeah, and I want to pass out a big thank you to all the people that are working very hard on converters, because it's so crucial to get models into the ONNX ecosystem.
Okay, for the ONNX TensorFlow converter, we support both TensorFlow 2.x and 1.x. In our next release, you will see two versions. One for convert to TensorFlow 2.x. Is it still sharing the screen? I'll keep going. So we're going to have two versions. One is for convert to TensorFlow 2.x model, and the other one for convert to TensorFlow 1.x model. If you want to get the latest code, then please go to our repository to download the code there. Our master branch support the conversion to TensorFlow 1.x. I'm sorry, 2.x. If you are looking for the support for the TensorFlow 1.x, you need to use our TensorFlow 1.x branch. And we are also planning to let users to save their converted model as saved model. We are in good progress on supporting OPSEC 11. You can see our latest ops support in our support status page in our repo. Another thing we add into our converter is dynamic input shape test. Dynamic shape input means you don't know the value of the input to the operator at the graph conversion time. You only know the data type and the rank of the input. You have the actual value at runtime. And we have encountered some issue in our converter that some conversion doesn't support dynamic shape input. Therefore, we add in some dynamic shape test to help us debug and verify our conversion support dynamic shape input. Jin, I'll pass it to you.
Jin, are you still there? Maybe we lost Jin for some reason. Let me see. Jin?
Hello?
There you go. Yes, Jin?
Hello, can you hear me?
Yeah, I can hear you now.
Hello?
Yeah.
Sorry, somehow my network got dropped. That's the, experience working from home. Anyway, so do you want me to continue talking about this?
Yeah.
Okay.
So, it's your slide now. Training
Yeah,
users
okay.
to convert.
We had some discussions on whether we do training or not, in which way, right? This is the first scenario. We believe, with the current ONNX inference model and graph, we should be able to take it to a backend, either a framework or converter. A runtime to execute it. Of course, to have this scenario working, the front end converters do not have to do anything, right? You just take the existing model and make it a train in the backend or a runtime. Of course, some kind of assumptions or defaults will be produced, right, for the training hyperparameters, loss functions, and optimizers. We heard MATLAB already did that in some way, right? So I like to hear the experience there. Maybe others can do the same. Okay, so that's the first scenario. It's quite straightforward. We can just use existing models. Can we go to the next one? The second scenario actually involves both front end and back end. As you can see in the chart, right? The front end converters will produce this ONNX trainable model, including everything for the training information, right? Then the back end converters either take it and train in the framework or train in ONNX runtime or some other runtime, basically. Okay. Of course, we assume the runtime can persist after a few iterations of training. As far as the framework converters, we have not decided whether it's going to be able to produce an ONNX model. Okay, but for sure, the framework should be able to just run or do the training in a particular framework, right? So let's move on to the next one. All right, I think that's the reason I put the vote there, right? The poll. I want to see whether most converters have or plan to support training, right? So as far as I can see, I think you can see that as well. It's actually splitting in 5. There are 5. From completely supporting to no plan. So it's pretty widespread, right? So here comes the question. So what are the practical and customer use cases? Do we have those models who want to take it from one framework and train in another place, right? So do we have more training APIs in the core to help, let's say, the backend converters and runtime to validate it works, right? So for this kind of questions, we will continue in our SIG discussions. So please join our meeting. Okay, thank you. Next one, please. I think we'll move on to the interesting new project, ONNX MIR. So Doro, please take over.
Yes, hello, can you guys hear me?
Yes.
Excellent. So yes, we started this project towards the end of last year, and considering our expertise in LLVM and both LLVM and ONNX, we decided, well, it's MLIR provided us with a way to connect the two really nicely. So if we go to the next slide, thank you. So one of the first things that I'd like to say is that MLIR opened the possibility for us to programmatically define and define new representations as well as transformations on these representations. So some of the things that we wanted to do is to create a representation for ONNX inside this, this infrastructure that was released in LLVM about mid last year. To that end, we decided to create ONNX MLIR, and what it does essentially, this is like a schema of it. What it does is that it ingests essentially the ONNX specification, and based on that, we automatically define what MLIR calls a dialect, which is a family of operations that create, that sort of capture the ONNX model breadth. So basically, we support all these operations. We are able to define them automatically and also perform transformations on them. So MLIR makes it easy for us to perform this because it supports a type of representation called table gen, which can be used as, let's say, a blueprint for defining these operations very succinctly. And then from that, it can automatically generate all the code and all the classes and all the C++ code that is used to define these objects. So we absolutely leverage all that functionality to define our operations, as well as to define transformations of these operations. So we have an ONNX dialect, which captures the semantics of the ONNX specification. There are several stages to this transformation, and one of the first ones is to infer all the shapes for all the operations. So given presented with a model, we can transform this model into its ONNX dialect counterpart, infer the shapes, and once that is done, we can actually perform transformations on this code. So we can make transformations that are both within ONNX, the ONNX dialect itself, and or we can transform this to other lower level abstractions. We have defined our own kernel, the kernel dialect, but also there are other out-of-the-box dialects that MLIR offers. And one of them being the LLVM dialect itself, to which we lower all the ONNX operations that the model contains. And then we are able to actually produce the LLVMIR corresponding to that. So basically, this would be like the end-to-end image of what our tool does. If we can go to the next slide, please. So this is how MLIR encodes an operation, and it basically, as you can see, it's very similar to how ONNX is represented, with a few, of course, representational quirks that MLIR adds. So it is it keeps track of all the inputs, the types of the inputs, and all the different attributes. This currently can happen. So for this example, for the convolution operation, and all we do is basically we use this to generate an essentially an ONNX dialect version of the input. So if you can go to the next one, please. In this particular example, this is an example of how TableGen is used. As I said, MLIR uses this to succinctly define operations. So basically what we do, we automatically transform the operators.md input into this type of representation, where each operation has its own definition, its own input and output types specified, and several other, let's say, attributes and traits, like, for example, that it supports shape inference, or it has no side effects. So all of this can be succinctly represented. From this, the MLIR infrastructure can actually generate the code. So if we can go to the next slide, please. Next slide. So yeah, that was an example of how we can define the operation itself, but we can also define transformations using TableGen. So this is a very simple merge operation where we can merge a mat multiply with an add, all using the pattern matching powers of TableGen. So all we need to do is specify that particular pattern that's in the middle of the screen, and then MLIR will do the rest. So basically it will perform the transformation, the conversion, if you will, from the top to the bottom automatically. And the next, please. So currently where we are with the development, so we are supporting several operations end-to-end, quite an extensive list that allows us to actually run NIST, the NIST model. We're currently working to run other models such as ResNet and several of the models that ONNX has in its model zoo. We're slowly adding that functionality. We're looking to add more tests in the future, and any contributions, external contributions that you guys would like to make or would like to learn more about the project, please don't hesitate to contribute and participate. Our project is now part of, as you know, it's under ONNX, so it makes it very easy for people to interact with us. So please get in touch.
Okay, I think that's it. Thank you.
Thank you. Yeah, so any questions for the presenter, for Chin or Gunther as well? Yeah, so Michael, I think Michael has a question for you, Chin. So there's a bit of tangential, to what the poll that you're doing, right? Right now, he's trying to figure out if ONNX will have a converter for any R-based or scalar-based converters, like ALE plots and influence agnostic. I'm not sure I know all of those to directly detect overfitting. Can someone answer that?
Maybe you can answer that offline because we're running short in time, Tom.
Okay. So yeah, Michael. Yes. Okay.
Yeah.
All right. So Michael, we'll answer your question in the chat or take it offline. All right. Okay. So with that, let's move on to the next speaker. So this is the model zoo. So let me stop. So Vinitra, are you on?
Yes, I am. Would you like me to share my screen?
Either way, yeah, if you have it
Yeah.
ready.
Sure.
Okay, maybe it's easier that way. Yeah, she's just free now. Thank you.
Great. So hello, everyone. Let me move this to the side, actually. Hello, everyone. I've recently taken over the leadership of the Model Zoo and Tutorial SIG, and I'm really excited to be here with you today. So first, I'd like to provide some updates and some information about what we're doing, since this is the first time the Model Zoo and Tutorial SIG has been launched. We kicked off in late January, and we've come up with a formalized charter on what we represent. Specifically, we're responsible for the collection of state-of-the-art ONNX models, as well as the ONNX Model Zoo and ONNX Models repository. And we're also responsible for making it easy for users to get started with ONNX and the ecosystem around it. This involves tutorials as well as the tutorials located in ONNX Docker. This also includes the first user experience, instructive blog posts, and technical conference participation. And so these are the main areas that we aim to work on in the next few weeks and months and so on. So I have some updates to share with you. Specifically, I want to talk first about what models we have as part of the Model Zoo. As you saw in Harry's original presentation, we have 31 models in the Model Zoo, which is up 24% from last year. We specifically have 28 vision models. Of those, 15 are image classification, 9 are object detection and image segmentation, and we have 4 other image models, including gesture analysis and image manipulation. We also have 3 machine comprehension models. So specifically, some models that I would like to call out that were recently added were ShuffleNet v2 and TinyYellow v3, as well as GP2 and the BERT Squad models, and then fast neural style transfer and super resolution. So with our efforts, we continually aim to add more models as we go on, and we welcome community participation in this as well. So some updates on what we've been working on in the last few months. If you go to the ONNX SIGs repository, you'll find a mission statement with all of the projects that we aim to work on, as well as our 10 core priorities, both on the Model Zoo side and on the tutorial side. So we encourage you to take a look at that. Other than that, we've proposed several models, and we're compiling a list of state-of-the-art models that we would like to consider adding to the Model Zoo that you can also find in the ONNX SIGs repository in our folder. And we've also decided to start tracking upcoming community ONNX events, and we hope to include this on the ONNX AI website going forward. Now, one of the main technical concepts that has been assigned to us or is in our charter is developing the Model Zoo CI. This was originally proposed, I believe, by Huawei a while ago, but we've decided to implement this in a slightly different way. The first step is to move all of our ONNX models in the Model Zoo to Git LFS, which is the large file storage system. The idea is if we include our Model Zoo models within the repository itself, instead of including links from various different file servers from various different companies and whoever the model implementer is, we, one, have an ability to download all models at once, as well as implementing a Model Zoo CI far more easily. And two, community users might find it much easier to select specific subsets of models or to find the locations without having to individually go to links in the README. So you can see our progress towards this initiative in issue 271, which is tracking our progress. Half of our models have been moved to LFS already, and we're working on the other half. And after that, we will soon work on the CI. The next main update is in regards to user experience. So we've developed 2 new ONNX Docker containers, ONNX Base and ONNX Dev, along with our third offering, ONNX Ecosystem. These 3 Docker containers will enable users to get started quickly with the published ONNX package from PyPy, as well as the Jupyter Notebook environment for getting started quickly with ONNX models. So in that, we have all of the different notebooks for the various converters and how to upload a model, convert it to ONNX, and getting started with inference using ONNX Runtime and other inference engines. So you can definitely check all of that out on ONNX Docker, but also these models are published, these images are published on Docker Hub. On our horizons in the next few months are guidelines. Specifically, we've proposed some Model Zoo and tutorial entry guidelines that we're iterating on to essentially standardize the experience of models in the Model Zoo. Additionally, we're working on discoverability. We want to expose these materials on the ONNX website. And this is in regards to the community events, but also in regards to tutorials and making sure users can find all the information in one place. We're also working on analytics. So we're tracking Model Zoo and tutorial GitHub usage and various others. We're looking for solutions in that. And that's one area we're focusing on, as well as participation. So like I mentioned, our first meeting was January 30th. We've had a few meetings since then. All of our meeting notes and recordings are located in our SIG's repository, so you can always follow up with that. And we have great members from Microsoft, IBM, and NVIDIA. We are always looking for more. And so at the end of this presentation, I will show you how you can get involved. That being said, I wanted to share some quick numbers. In terms of Model Zoo traffic, I just pulled data from the last 2 weeks based on GitHub traffic. We've had around 5,000 unique visitors with 20,000 views, which means that each visitor is visiting multiple pages in the Model Zoo. And specifically, some of the most common pages, or the most popular models that can be inferred from that, are ResNet, MobileNet, and TinyYOLO v2. Additionally, ONNX Tutorials is seeing a lot of traffic as well. We've seen 46 clones in 2 weeks. And specifically, we've seen over 10,000 views with 3,000 unique visitors. And we can see that some of the tutorials regarding PyTorch, TensorFlow, MNIST, and model visualization are the most popular. So more analytics are coming forth in hopefully our updates in the next meetings. But what we'd like you to do is join us on Gitter, join us on GitHub. Our next meeting is next week on April 13th at 1 p.m. The links will be in the Model Zoo Gitter, and we welcome everyone to join us. We can always use the extra help, and I look forward to giving you more.
For Vinitra? All right, I know that we're gonna run a little bit over. I know it's come up at 12 noon right now, but so let's move on to the next one. Thank you, Vinitra, for your presentation.
Sure.
Okay,
Thanks.
and so Svetlana, I think you're next. And this is gonna be the last update for the SIG and working group. Svetlana, go ahead. Or would you rather that I share screen?
I'm sorry, after I shared, I could not unmute myself. So wrong order.
All right, why don't you go ahead? I have your screen up now, your slide up. Go ahead, Svetlana.
Okay, just a second.
Okay. No.
Oh no.
I already shared screen. So you can talk to your slides. You want me to do that?
Okay, can you see it now?
Yeah.
Okay,
You can
good.
go to full
Yeah.
screen slideshow mode.
Yes. Sorry about that. Yes. Hello
Okay.
all. Again, I'm Svetlana Levitan, and I'm leading the ONNX training working group. And today I will, I know we are already out of time, so I should be very brief. So I will just give some background and briefly talk about the new features that ONNX training is bringing into this release and our next steps. So the working group was created more than a year ago, and I have been leading it, but the main work actually was done mostly by Wei-Sheng Qin from Microsoft. And so basically, yeah, we have a number of pull requests that have Wei-Sheng mostly created with some input from other people. And it is going into ONNX 1.7 release, as has been mentioned already. But ONNX runtime and converters do not yet support this ONNX training, so it's more like a preview feature. Now, why do we need ONNX training? Well, sometimes training is actually a part of deployment. Sometimes people may want to somehow refine the model that they have already deployed, or perhaps retrain on new data or something like that. And so there was a lot of interest in creating this new spec in ONNX to allow the training information to be included, not just the model for inference. And so we were working on this for a long time, and the idea is that yeah, we'll have one framework that allows all the information be kept in one place. And it also provides more flexibility for these computation-intensive workloads. As you know, deep learning is often very computational intensive, and some people wanted to be sure that if they deploy the training job into some parallel computation systems, that they would be getting consistent results with training on a single computer or something like that. And many hardware manufacturers were also very interested in this as well, especially in Intel and NVIDIA. So this is a brief summary from the PR about training. So basically, and fortunately today, this was already described by Rama. So maybe we don't need to spend too much time on it. So basically, we now have this new message training info proto that includes initialization algorithm, initialization binding, and update binding. And all this goes into the model proto. So this is the edition that contains all this training information that is needed. And in terms of new operators, the two core new operators are gradient and graph call. And in addition, we have, I'm not sure, I think those are functions, right? For loss functions, those are not operators, but functions, because it's a combination of a number of operators. And there are new optimizers, the new, I'm not sure if those are operators or functions, but we have the optimizers. The last one, Adam, I think I did not get into 1.7 release, or I'm not sure exactly about that one, but the first two definitely got into that. And all these new operators or functions are in the new domain, ai.onx or onx.training, and you can find them there. So in terms of the next steps, one of the issues that my colleague Chin raised was that we need some examples of ONNX training models so that the converters can work with them. So we will work with Wei-Sheng to create some examples. And in terms of gradient, well, as you know, by chain rule, we have to have gradients for all the operators in ONNX to be able to compute gradient of the composite function. So we'll have to divide this work because, as you know, ONNX has more than 100 operators. So we need to create those gradients for probably all of them or most of them. That would be a lot of work that we need to add into documentation for each operator, what the gradient is. And also we need to create helper functions in ONNX so that it's easy for people to create some training info proto, and so that they could take a model which has just inference information and create a training model out of it, and the vice versa as well. So if you have a model with training, maybe they want just to use it for inference, then we need to be able to remove the training info. So we will work with converters teams to help them support ONNX training and see if they find any problems with the current spec. Then we need to update the spec to make sure it actually works well. And also we need your answers about whether we need to include autodiff into this ONNX spec, or autodiff would be done by converters or runtime. So we'll need to discuss this, but unfortunately now we're out of time. Well, that's basically it, I think. Any questions, comments?
Yeah, hi, thanks, Svetlana. I think there's one question from Adam. He asked, when a model has been trained using the ONNX training support, how much information about the training is persisted in the inference model? For example, gradient, optimizer parameters, amount of data, and etc.
That's a great question. So I think currently, I believe there is some place in ONNX where some metadata can be placed, and depending on where you are exporting from, the model producers might be putting some of that information into the model for inference, but I'm not so sure if they do.
Right.
Go ahead.
I guess the question is that, do we preserve the optimizer state, like momentum or number of training iteration has been conducted?
So I don't specifically mean the state. I do mean like the hyperparameters of the optimizer, like what the momentum parameter was set to, rather than the momentum values during training. Because tracking a model from training all the way through to inference is really useful, because then you know what the parameters were when you get some random model. You have to try and recover how to train it.
Yeah, so for optimizer parameters, they are stored in the attribute field of your optimizer, because an optimizer is just an operator, and an operator can have many attributes.
I think this question is not really about model training spec. It's I think it's more about just model metadata in already existing ONNX, right?
I think the model format allows a user to store this information, but it is up to the model creator and exporter to make sure it stores the necessary information.
Right. Yeah, I agree. So do we know if current model producers actually store any of that information?
No, I don't know.
Okay, I believe the training spec doesn't require training info to be there, right? So when you produce an inference model, you can just ignore that part. Right?
Yes.
The inference graph still works.
Right.
Yeah.
Yes. Yes.
Okay.
Yes.
Of course, if you don't do anything, training info could be there. But if you just want to make it optimal for inference, just totally ignore the training info proto.
Yeah.
Yeah, that's right.
Okay. Any other questions? Well, thank you all very much.
All right.
Thank you for sticking with us for so long.
Thank you.
All right. It's okay. So thank you, everyone. I guess that bring up to the end of the workshop. So Again, I'd like to take this opportunity to thank all of you for your participation today. I know many of you asked about the recording and material from the presentation today. They'll be made available sometime soon. Expect that we will send out an email to follow on this, and as well as share that on the mailing list. Okay, so please stay tuned and check for that. If there's one thing that I would like to ask of all of you is to please stay engaged and continue to contribute to ONNX and help make ONNX be successful.
Hey, quick question on the recordings posting. I know it's going to be on the ONNX GitHub and as well as on the LFAI event page.
Yeah, we will send you the detail where the link. Yeah, you get the detailed information exactly where to find them.
Okay, wonderful. Thank you.
I'm not sure. Yeah, I'm not exactly sure where, but yeah, it will be one of those places. But you get the exact link, so you don't have to go and hunt and search for it.
Yeah, you can put it on GitHub, but link can be made on the LFA page, wiki page.
Yeah. Well, we'll let you know. Yeah. Okay. And then please remember to use the different ONNX resources listed here. Right. Go to our website, ONNX.ai. Go to GitHub, Gitter. But more importantly, join the mailing list. I think that's where you can get the information that we want to announce to everyone. All right. But more importantly, please again stay engaged and continue to contribute. All right. So with that, on behalf of I guess IBM, LFAI, and also the ONNX steering committee, I want to thank you for joining today. So Prasant and Harry, you have any final comments? Last word?
No, thank you everyone for joining and for your ongoing participation. Please do sign up for the ONNX Announce email list. That's how a lot of information will be communicated out.
Great. All right. Thank you, everyone. I'm sorry we're a little bit over, but I think it was a great session and hope that you find it useful and informative.
Thank you.
Thank you so much.
Tom, signing off now. Thank you. Thank you, everyone. Bye.